In this video, we're going to do the third example of setting up a triple integral given a 3D shape. With this shape, we know that it is bounded by the planes x plus z equals 1 and y plus 2z equals 2. Now for this problem, it will be easiest if you don't put dz in the inner boundary. Okay, so you set your triple boundary. Now, we could either put dx or dy first. I'm just going to put dx first, then dz, then dy. But I could do dx, dy, then dz. Okay. As long as dz is not first, we're good to go. We could set it however we want. Now, to find the inner boundary for for dx, you want to take this equation because it has an x and solve for x. X equals negative z plus 1. This will be your upper boundary for this inner integral. So negative z plus 1. And the lower boundary would then be 0 because this shape ends at when x is equal to 0. Okay, to find dz dy, you want to draw a 2D shape using this equation. And because we're solving for dz first, we're going to solve for z here. First, 2z equals negative y plus 2. Divide 2 on all of these. You get z equals negative 1/2 y plus 1. Okay? So you could put z here and y here, or y here and z here. It doesn't matter. I'm just going to put y here and z here. Now add your points. The z-intercept is 1, so z-intercept is here. And the slope is negative 1/2 y, so rise negative 1, run 2. You get this line. Now, back to the boundary for dz. We solve for z here, therefore the boundary for dz is negative 1/2 y plus 1. And the lower boundary will be 0 because if you do a slider for dz, it would look like this. So it goes up only to this line, and it could go down to 0. Now, if you want to find dy, your slider will look like this. And you could go from left to right. And when you go left, you can only go left until this point, which is 0. So your lower boundary is 0. And right this point, which is 2. So your upper boundary is 2. So this will be your triple integral setup for this 3D shape right here.